Okay, so today we are going to solve paper 2, October November 2019, and it's 22, paper 22, right? And those who have not subscribed the channel yet, kindly do subscribe it and press the bell icon so that you get the notifications for new lectures, right? So let's just start with the questions. And the first question, it says that in the periodic table, the p block contain elements whose outer electrons are found in the p subshell, right? So they're talking about the p block of the periodic table. And I hope you know this thing that basically periodic table has four blocks. It contains four blocks: S block, and then D block, this is P block, and this is F block. So this is called S block, which contains group 1 and 2. This is D block, which contains the transition elements, and this is P block, which contains elements of like third group, fourth group. So this is six groups present in P block, and then this is F block at the bottom of these blocks, right? So if an element is present in P block, that means its valence electrons will be present in P subshell. And if an element is present in S block, that means its valence electrons will be present in the S subshell, right? So this is what a block will represent. So in the question, it says that the P block elements contain elements, or P block contain elements whose outer electrons are found in the P subshell. Okay. So the first part is elements in the P block shows a general increase in first ionization energy as the atomic number increases. Draw the shape of a p orbital. So in the first part, they're just asking us to draw the shape of a p orbital, and p orbital, it is a dumbbell shape. So you can draw either px or py or pz along x-axis or y-axis or z-axis. So let's suppose this is a p orbital, right, or something like that. All right, and the next question is write an equation to show the first ionization energy of silicon. So what is ionization energy? It is the energy required to remove 1 mole of electron from 1 mole of gaseous atom. So that means silicon must be in gaseous phase, right? So silicon will be in gaseous phase. So 1 mole of electron from 1 mole of gaseous atom to form 1 mole of gaseous ion, because silicon, when it loses electron, it will convert into a positive ion, and this will also be in gaseous phase. So this is the first ionization energy of silicon, right? Again, I will repeat the definition, that it is the energy required to remove 1 mole of electron. This is 1 mole of electron, to remove 1 mole of electron from 1 mole of gaseous atom. So this is 1 mole of gaseous silicon to form 1 mole of gaseous ion. So when silicon will lose 1 electron, it gains +1 charge, right? And here we have 1 mole of silicon, and it releases 1 mole of electron to form 1 mole of gaseous ion. All right, now in the next part, they're saying explain why there is a general increase in first ionization energies of the elements across period 3. All right, so if I just write period 3 elements here, period 3 elements, it contains sodium, magnesium. These are from S block. Then after sodium, magnesium, then we have aluminum, silicon, phosphorus, sulfur, chlorine, right, and argon. So as we move across the period, if we move across the period, the ionization energy increases. There is a general increase in the ionization energy, although there are few exceptions. But in this question, they are not asking about the exceptions. They are talking about a general increase. Why there is a general increase in first ionization energy of the elements across period 3. So I hope everyone knows this thing. The 3 factors which affect the ionization energy. Number 1 is factors which affects the ionization energy. So the number one is nuclear charge, or the number of protons, which is directly proportional. Number two is atomic radius, which is inversely proportional. As radius increases, ionization energy decreases. Atomic radius. And the third one is shielding effect, or you can call it a screening effect. So I hope you know this thing, that across the period, atomic radius and ionization energy, across the period, atomic radius and atomic radius and shielding effect, they both almost remain same, right? So the thing which changes is number of protons. Sodium has 11 protons, magnesium 12 protons, aluminum 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, and argon 18. So that means the number of protons are increasing. Nuclear charge is increasing, right? So as nuclear charge increases, it would become difficult to remove electron, because the hold of nucleus would get stronger, right? So we can say that why there is a general increase across the period. So the answer would be, across the period, the nuclear charge increases, shielding effect and atomic radius almost remains same. So it would be difficult, or we can say the hold of nucleus on electron increases across the period, right? As we move across the period, because number of protons are increasing, so the strength of nucleus is increasing, and it will become difficult to remove electron, because atomic radius, number of shells are same across the period, number of shells, all these elements belongs to third period. That means the valence electron is present in third shell, right? So that means atomic radius is same, and if radius is same, number of shells are same, that means shielding effect would also be same. And if these two factors are same, if there is no change in the shielding effect or atomic radius, that means on increasing nuclear charge, it would become difficult to remove electron, and ionization energy will increase. There will be a general increase in the ionization energy. All right, so the next question is, element A is in the P block. All right, we don't know what is element A. They've just given us that element A is in the P block. The graph shows the successive ionization energies for the removal of first 10 electrons of A. So on y-axis we have ionization energies, on x-axis number of electrons removed. So the graph shows the ionization energy for the first 10 electrons of element A. And now they're asking, state and explain the group of the periodic table that element A belongs to, right? They have just told us the block in which element A is present, and now we have to find out in which group element A is present, and then we have to explain it. So by looking at this data, you can see that there is a large increase in the ionization energy from third electron to fourth electron, right? This is the ionization energy for the third electron, and then this is the ionization energy of the fourth electron. So the ionization energies are increasing from first to second, it increases, then third one also increases, but there is a large increase if we just join these points. So let's suppose this is first, second, and third, and then between third and fourth there is a large increase. And whenever there is a large increase in the ionization energies, whenever there is a large increase in the ionization energy, it represents a shell change. That means we have moved closer to the nucleus. So let's suppose although as like we all know this thing, that successive the ionization energy increases, the second ionization would be greater than the first one, third ionization would be greater than the second one. And the reason is, when we remove, let's suppose if I write we just simply write the equations for the first, second, and third ionization energy of element A. So let's suppose if this is element A, it would be in its gaseous phase. It removes first electron and it goes into ion phase. So this is the first ionization energy. Now, in when it loses the second electron, it is already a positive ion, and a positive ion means a strong attraction for the electrons. Right now, there will be a stronger attraction for the electrons. The effective nuclear charge has been increased. Right, so now it would be difficult to remove electron. Just remember this thing, that it would always be difficult to remove electron from a cation than from an atom, because a cation means it has a higher nuclear charge, it has more protons than electrons, so it would be difficult to remove electron. So successive ionization energy is always increased. So second ionization energy would be greater than first ionization energy, and the third ionization energy would be higher than the second ionization energy, because in case of third ionization, the effective nuclear charge has increased more. Now we are removing electron from a 2 plus ion. Previously it was plus 1 ion, now a 2 plus ion, so effective nuclear charge has increased more, so it would be a higher ionization energy. So just remember this thing, that successive ionization energies always increases. But there is another factor which affects the ionization energy, and this is the distance of electron from the nucleus. So let's just assume that this is element A or atom A, and this is the nucleus of atom A, right? And it loses 3 electrons from this shell. This was the valence shell. And after these 3 electrons, the 4th electron is being removed from the inner shell. So the distance is now decreased. The distance of nucleus from the valence electron is now decreased, right? And as the distance decreases, ionization energy increases. It would become difficult to remove electron. So previously there was in the case of these 3 electrons, only nuclear charge was increasing. Only nuclear charge was increasing, right? But in the case of this 4th electron, nuclear charge has been increased, because now we are removing electron from a plus 3 ion, right? And in addition, the distance is also decreased. So whenever there is a large difference between two successive ionization energies, that means there will always be a difference between two successive ionization energies. But whenever there is a large difference, that would indicate a shell change. That means we have moved closer to the nucleus. The electron has moved closer to the nucleus, or the electron is being removed now from a shell which is closer to the nucleus than the previous one, right? So a large increase in the ionization energy, that would indicate a shell change, and that means the element A belongs to group 3, because it has 3 electrons in its valence shell, and the number of electrons present in valence shell would give us the idea about its group, right? So if an element has 1 electron in its valence shell, that means it belongs to group 1. If an element has 2 electrons in its valence shell, that means it belongs to group 2, and if it has 3 electrons, that means group 3. So it has 3 electrons in its valence shell, so that means it belongs to group number 3. And the explanation is that there is a large increase between third and fourth ionization energy. Alright, so I hope you get this point. So whenever there is a large increase in ionization energy between two ionization energy, that means it is a shell change, and you can easily tell that from which group this element belongs. Alright, Now, the next question is silicon is found in many compounds in the earth crust. Silicon is only three naturally occurring isotopes, silicon 28, 29, and 30. The table shows data for silicon 28, 29, and 30. So these are the relative isotopic masses of these three isotopes. And a sample of silicon contained 92.2% silicon, because you know this thing that the relative abundance of isotopes is not same. So Si28 has a relative abundance of 92.2%. The total percentage abundance of 29 and 30 in the sample is 7.8%. Right? So the abundance of silicon 28 is 92.2%, and the total percentage abundance of 29 and 30 in the sample is 7.8%. The relative atomic mass of the silicon in the sample is 28.09. So we have relative atomic mass as well. Now what we have to find out, calculate the percentage abundance of silicon 30. We have to calculate the percentage abundance of silicon 30. They have told us this thing that the total percentage abundance of silicon 29 and 30 is 7.8%, and we have to find out the abundance of silicon 30. Give your answer to one decimal place. All right, so the information which we have here is that the relative atomic mass of silicon is 28.09. So this is the weighted average of all three isotopes. The abundance of silicon 28 is 92.2%, and the abundance of silicon 29 and 30 in the sample is 7.8%. So let's just say if I represent the abundance of silicon 29 by X and the abundance of silicon 30 by Y. So X plus Y would be equal to 7.8, and X would be equal to 7.8 minus Y. All right, and we have to find out the value of Y. Okay, so the formula for relative abundance to find out the relative atomic mass of an element from its isotopic masses and their relative abundance is that relative atomic mass of that element, so AR of silicon is equals to the isotopic mass of silicon 28, which is 28 multiplied by its relative abundance, which is 92.2. So we just have to multiply the abundance of each isotope with its mass. So 28 is the isotopic mass of silicon 28 and 92.2 is its percentage. Then the next isotope, all these percentage abundances would get summed up. So the next isotope is silicon 29. So its isotopic abundance is 7.8 minus Y, plus the third isotope is silicon 30 and its abundance is Y, which we have to find out, divided by 100. All right, so relative atomic mass of silicon is already given in the question, which is 28.09. So this is 2581.6 plus 29 into 7.8, which is 226.2 minus 29y plus 30y, right, divided by 100, and this 100 would be multiplied by 28.09, so this would become 2809 is equals to 2807.8 minus plus y. So y would be equal to 2809 minus 2807.8, which is equals to 1.2. So y is equals to 1.2%, and this is the percentage abundance of silicon, and we have to give the answer up to one decimal place. So this is 1.2%, right? And that means silicon 29 would be, if you just simply subtract it from 7.8, you can get the percentage abundance of silicon 29 as well. But they've only asked about the percentage abundance of silicon 30, so this is the answer. Now, next question is, silicon reacts with nitrogen gas to form Si3 and 4. Si3 and 4 is a solid with a melting point of 1900 degrees centigrade. It is a solid with a melting point of 1900 degrees centigrade. It is insoluble in water and does not conduct electricity when molten. Suggest the type of bonding and structure of silicon nitride. Explain your answer. So you get a lot of these kind of questions where they'll give you some sort of physical properties and then they'll ask about the type of bonding and structure of that particular compound. So it has a high melting point. It is insoluble in water, does not conduct electricity. So a high melting point and insoluble in water, so it suggests that it is a giant molecular structure because it does not conduct electricity. It is insoluble in water. We have two substances which have high melting point. One is ionic substances and the other one is giant molecular structures, right? Either it would be an ionic compound. A high melting point suggests that either it would be an ionic compound or a giant molecular structure. But the other two properties are that it is insoluble in water and it does not conduct electricity. This suggests that it would be a giant molecular structure. So we can simply say that structure would be, it would be a giant molecular structure, right? Type of bonding would be a covalent bond, contain large number of strong covalent bonds due to which it has a high melting point. It contains large number of strong covalent bonds due to which it has a high melting point. Just remember this thing, that giant molecular structures, they do not have any kind of intermolecular forces, no weak forces. And why it does not conduct electricity? Because, and it does not have any free electrons available. So all its electrons would be involved in the bond formations in covalent bonding. So it does not have any free electrons, right? So this would be a simple answer. Next question is, sulfur containing compounds such as this one, C2H5SH, are found in fossil fuels, are produced sulfur dioxide when they are burned. Write the equation to show the complete combustion of C2H5SH, right? So this is a thiol, and we just have to write the equation, the combustion equation for this compound. They've already told us that when this would get combusted, when it reacts with oxygen, it produces sulfur dioxide. So C2H5SH, when it reacts with oxygen, whenever combustion would be done, we get oxidized products of all the elements. So we get carbon dioxide, water, and sulfur dioxide. Now next we have to balance this equation. So 2 moles of carbon here, so that means it would be 2 carbons, 5 plus 1, 6. So that means 3 hydrogens, 3 moles of hydrogen, and 1 sulfur molecule, 1 sulfur atom here, 1 sulfur atom here. Next we just have to balance oxygen. So 2 2s are 4, 3 1s are 3, and plus 2. So 4 plus 3, 7, plus 2, 9. So it would be 9 upon 2. An odd number can easily be balanced. Just place the odd number and divide it by 2. So the equation is now balanced, right? State why the presence of sulfur dioxide in the atmosphere has environmental consequences. The presence of sulfur dioxide in the atmosphere, the environmental consequence is acid rain, because the sulfur dioxide, it dissolves in water, it dissolves in rainwater, lowers its pH, or it forms sulfurous acid, H2SO 3. Describe one of the consequence on the environment. So you can write any consequence of acid rain. It damages trees, kills fish and other marine life, destroys or erodes buildings, right? So any one of them. Sulfur dioxide can react with ozone to form sulfur trioxide. Sulfur dioxide reacts with ozone to form sulfur trioxide in two different reactions. In one reaction, sulfur dioxide reacts with ozone until a dynamic equilibrium is established. State and explain the effect of an increase in pressure on the composition of the equilibrium mixture. So what is an equilibrium? When rate of forward reaction becomes equal to rate of this is a reversible reaction. So in a reversible reaction, when rate of forward reaction becomes equal to rate of backward reaction, this is called a chemical equilibrium. Now they're saying that if we increase there are three factors which disturbs the equilibrium: temperature, pressure, and concentration. And this time they are changing the pressure. So if we increase the pressure, state and explain the effect of increase in pressure on the composition of equilibrium mixture. So pressure affects only those systems where gases is involved. And yes, in this system you can see that gases are involved. So we have all gases present in this equilibrium mixture. But in addition to that, first of all, gases must be involved and number of moles of gas must be unequal on both sides. To get an effect of pressure on the composition of equilibrium mixture, number of moles of gas must be unequal. And if you calculate the number of moles on both sides, so on reactant side we have 2 moles of gases, 1 mole of sulfur dioxide, 1 mole of ozone. On the product side we have 1 mole of sulfur trioxide, 1 mole of oxygen. So on both sides we have 2 moles. So that means no effect of pressure, as number of moles are equal, number of moles of gas are equal on both sides. All right, and the last part is, in the other reaction a different equilibrium is established at 300 Kelvin as shown. So this is a different equilibrium and this established at 300 Kelvin. Suggest a temperature, and the delta H for this reaction is plus 462.3. That means this is an endothermic reaction. Suggest a temperature needed to increase the yield of sulfur trioxide at equilibrium. So yield of sulfur trioxide, we have to increase the yield of sulfur trioxide, and to increase the yield of sulfur trioxide, that means we need to perform the forward reaction, and forward reaction is endothermic in nature, which favors high temperature, right? So if you want to move in that direction where endothermic reaction is happening, you have to increase the temperature, right? So that means suggest a temperature. So the temperature would be, it would be any temperature higher than 300 K. So we can say 400 K, because forward reaction is endothermic. Forward reaction is endothermic, so it favors high temperature. All right, so this is it for question number 1.